What is up, mathletes? Welcome back to another episode of Math with Dr. Math, and today we're going to talk about zeros and multiplicities. All right, so let's dive in here and let's see what the heck this is. So remember, just before we begin, zeros are really our x-intercepts here, right? So we could see at -4 we have a zero, at -3 we have a zero, at -1 we have a zero, at 2 we have a zero, and at 4 we have a zero. But sometimes when we're solving these functions, right, we might get, let's do an example real fast. Let's say I'm looking at x minus 2 squared, and I'm looking at this function, and then I'm interested in finding its zero. So what I would do is I would set the function, right, the height equal to 0, and notice I have x minus 2 squared, so I really have 2 copies of x minus 2, all right? So this right here is an example of whatever zero I get that has a multiplicity of 2, because its factor, you see it listed twice. So when I solve this, right, what I would tend to do is I would set each one of these factors equal to 0. Here, I wouldn't have to actually set each one of those equal to 0, because look at my answers. They're the same. So when we're saying the multiplicity, like how many times do we see that 0 appear when we're solving these equations, right? That's the way I want you to think about these, all right? So when we talk about multiplicity, this is what I want you thinking about. So when it gives you a 0, you know, how many times did you see its factor, right, show up? So why is that important? Well, what that's going to help us do is it's going to help us decide, you know, when we're graphing this, is my function going to go through, we say go through the x-intercept, right, from the negative direction here and end up in the positive side, or is it going to do like right here at -1, is it going to bounce back? Is it going to be a touching point? What does that mean? Notice my graph is coming from the negative y direction, and then it touches my x-intercept and then it bounces back, right? So that's what it means. That's how our multiplicity is going to impact our function. It's going to tell us, is it going to go through that function, right? Like here, so here I know I have an odd multiplicity, or is it going to touch it and then come back? And if it does this, then I know my multiplicity is going to be even, all right? So that's how our zeros and their multiplicities are going to help us. So let's actually see this in action. All right, so let's say they provide us with this function right here, this graph, right? It's smooth and continuous, so we know it's a polynomial function. All right, so assuming no funny business is happening, this looks like your basic cubic function. All right, but let's dive in here. First, let me go ahead and point out the zeros. So we have a 0 right here, right? One of our x-intercepts at -1. So let me list them. X equals -1, that's one of my zeros. Then I have another x-intercept right here at 1. So x equals 1. I have another x-intercept right here at 3. So x equals 3. So remember, when these are our x-intercepts, we also know that we have the factors, right? For our polynomial here, we have our factors of x plus 1, right? That's associated with this 0 right here. Then I have x minus 1, and that's going to be associated, that factor is going to be associated with this 0. And then we have another factor of x minus 3, x minus 3. That's associated with this 0. And just look at the relationships here, right? The x-intercepts and the factors, right? These signs right here are always the opposite. All right, so make sure you keep that in mind. All right, notice we only had one copy of each. So what that tells us is that their multiplicity, right? Those exponents, how many times did they appear? Exactly once. So these all have odd multiplicity. So each one of those factors has an odd multiplicity. What does that tell us? Well, what that means is that as I'm graphing this, I know that my function is going to go through that point. It's not going to bounce back down, right? If it had an even multiplicity, right, what you would see is we would see our graph going here, and all of a sudden it would touch it, and then it would bounce back down. That's what an even multiplicity would do. So as you're out there looking at your problems, That's what the multiplicity is going to help you when it's your turn to graph these. All right, so let's go ahead and let's look at some functions and start from the beginning. All right, mathletes, so let's look at this problem and look what they want us to do. They want us to find the function and state the multiplicities, and we already know before we even begin, you got to smash that like button, subscribe, and tell a friend or 10,000 about what we're doing here in Dr. Math Studios. All right, so finding the zeros, what that means is we're finding those x-intercepts. So we're gonna set our function equal to 0. And this is where all our algebra skills are gonna come into play. So in this case, you wanna make sure that your factoring is sharp, right? Because hopefully we could factor this. In this case, it looks like we could factor out a 2x, right? So let's factor out that greatest common factor, which is 2x, right? And what are we left with? What are we left with? We're left with the 4x squared plus 7x minus 15. All right, how did we get that? All we did when we factor this out, remember, you're just dividing each one of these terms by a 2x, right? 8 divided by 2, 4. 14 divided by 2, 7. Negative 30 divided by 2, negative 15. And if you want to check your work, distribute, and you better get back what you started with. All right, can we factor this trinomial? Right, so again, make sure you understand and you know how to factor. So over here, let me go ahead and use the AC method. We have so many methods to choose from. I'll just use the AC method. All right, so what does that mean? Well, we're going to multiply our first and last term, right? So we get negative 60 because you get 4 times negative 15. And all we're doing is factoring. So however you like to factor, use that method, right? Then you take that middle term, that 7, a middle coefficient. We throw it down there, and we're looking for two factors that multiply to give me negative 60, right? So I'll put a little multiplication sign. They're going to multiply, give me negative 60, and they're going to add to give you 7. Some of you are really sharp with your multiplication. So like what you could do is just think of those numbers in your head. A lot of folks, they need some type of method to follow. So what I tell people is get out your calculators and don't even worry about your signs, right? Do 60 divided by 1, we know it's 60. 60 divided by 2, you get 30. 60 divided by 3, you get 20. And this method, I just keep dividing, right? What you're gonna see is that it's gonna take seconds, right? Because what you're looking for, right? After you find possible factors, right? These are all the possible factors, ignore the signs, right? Then when you add these two, now we could throw in some signs. Is there difference, right? Because the signs are going to be different. So that's why I said they're difference. Is the difference going to be 7? So I go through my list here. Nope, nope, right? Are the difference. So if I subtract them, is there any way I could get 7? 20 and 3, I'll get 17. 4 and 15, I'll get 11. 12 and 5, we got a winner, right? And notice this 7 is positive, so that means our bigger number is going to be positive and our smaller number will be negative. So negative 5 times 12, let's look at this. Negative 5 times 12 gives me negative 60, but when I add them, it gives me a positive 7. So what I'm going to do is I'm going to use these two factors to rewrite this factor. So let me just focus on the 4x squared plus 7x, plus 7x minus 15. And what I'm going to do is I'm going to replace that 7. So I got 4x squared, I'm going to use my two new factors, minus 5x plus 12x minus 15. So when I add these, right, that just replaces the 7. Why did I want to do this? Because now I could use factor by grouping, right? I could use factor by grouping there. So now I look at the first two terms, I say, what do they have in common? Well, they have an x, so I'll factor out the x, and I'm left with 4x minus 5. I look at my next two terms, what do they have in common? Well, they have a 3 in common, so I'll factor out a plus 3. What are you left with? A 4x minus 5. What do you notice, right? These are the same, so I could factor out a 4x minus 5. So let's go ahead and factor that out. we factor out a 4x minus 5, and when you factor it out, right, notice what you're left with. So you're kind of thinking of this as you're canceling it. So you're left with the x plus 3. You're left with the x plus 3, x plus 3. So here we have factored it. Why do we do that? All right, so let's go ahead and now we're gonna rewrite this, because remember your ultimate goal, we're trying to find the zeros. So let me throw that back in here. We get 0 equals 2x. Let me throw in my two new factors, 4x minus 5 and x plus 3. So now everything's factored as much as possible. So let me get my eraser, give myself some more space here. So everything's factored as much as possible, and now notice that multiplication equals 0. So we could use our zero product rule. What does that mean? Well, that just means if this product equals 0, one of those, at least one of those, has to be equal to 0. So what we're gonna do is we're gonna set each of them equal to 0, right? And this is how we're gonna find our zeros. So let's solve each one. Divide by 2, divide by 2. So we get x equals 0. And what I also want you to pay attention to is look at the exponents associated with each one of these factors. X plus 3 appeared once. 4x minus 5 appeared once. I only had one x. So each one of these zeros has a multiplicity of 1. If this were x plus 3 squared, then that x plus 3 would have a multiplicity of 2. All right, so some things to pay attention to right there. Let's continue the march. Let's add 5 to both sides. So you get 4x equals 5, divide by 4, divide by 4. So x equals 5/4, right? And then our last one, that's easy. Subtract 3 from both sides and you get x equals -3. All right, so now we have each one of our zeros, right? And each zero has a multiplicity of 1 because they each appeared only one time. All right. And so again, what I want you to think about is think about the relationship between the zeros and the factors as well. Because look, the zero is -3, but the factor is x plus 3. So make sure you're careful with those signs. All right, so let's do another example because I think you're starting to get the hang of this. All right, mathletes, so let's look at this problem. And this one brings a smile to my face because this is already 4 terms. So just like that last term at the end, we use the grouping method. So let's go ahead, since we're looking for the zeros here, let's use the grouping method. So let's first set everything equal to 0, of course, because we want to find those zeros. All right, and then what we're going to do is we're going to group those first 2 terms and the last 2 terms. And we're going to see, what do the first 2 terms have in common? Factor that out. What do the second 2 terms have in common? Factor that out. So let's do that. So we get 0. The first 2 terms have an x squared, and they leave us with the x plus 3. Nice. The second 2 terms, pay attention to this. We always want to bring down that sign that's between them. So bring down that negative, and looks like they have a 25 in common, and we're left with the x plus 3. Why plus? Because remember, you factor out the negative, so that means you're going to change these signs, right? So all these little details pay attention to, right? So let me highlight so that you could see they both have an x plus 3, which is great news, because what that's going to tell us is that we can factor out that x plus 3, because that's what they have in common, right? So they have the x plus 3 in common, and what is left if you pull out the x plus 3? Well, they have that x squared minus 25. So I'll remind you, when you're factoring out the x plus 3, right, pretend those are gone. What are you left with? That x squared minus 25. And if you want a little color coding there, the x squared minus 25 is what's left. So that's how we got right there. And you always want to ask yourself, can I factor further? So that x squared minus 25, that looks like a difference of squares, right? So let's go ahead and factor it out. Remember your difference of squares formula. A squared minus b squared equals a plus b, a minus b. And what I like to tell folks is just take the square root of this, that's your a, take the square root of this, and that's your b. So x and 5. So let's go ahead and factor that. So you get 0 equals x plus 3, x plus 5, and x minus 5. And there you have your mother factors, right? 1, 2, 3 of them. So now we could go ahead and find our zeros. And notice each one of these has a multiplicity of 1. So let's go ahead and you get x plus 3, x plus 5, and x minus 5, right? So each one of these, that's what we have here. So we're going to solve, we're going to subtract 3, we're going to subtract 3. So you get x equals negative 3, subtract 5, you get x equals negative 5 as your next zero, and then add 5 and add 5, and you're going to get x equals 5. So these are your x-intercepts, and again, pay attention to the relationship between the x-intercepts and the factors. So if you know a factor, right, if you have a factor, you automatically know x-intercept. If you know the x-intercept, then you automatically know its factor, the factor. All right, and it says state the multiplicities. Notice none of these were repeated, right? I didn't have an x minus 5 to the third power. I didn't have an x minus 5 squared. So each of these appeared one time. So it's multiplicity, right? For each one, this has a multiplicity of 1. This has a multiplicity of 1. This has a multiplicity of 1. All right. So what does that mean, right? Because I think I get that question a lot. So let me erase this formula here and let me do a little etch-a-sketch for you to show you what that means. All right, so let's do a little etch-a-sketch here just to show you what that means. So notice I have my zeros at negative 5, 1, 2, 3, 4, 5. We got a 0 right there. At negative 3, 1, 2, 3. We got a 0 at 5. 1, 2, 3, 4, 5. All right. And what I'm going to do here is I know that my degree is odd and I know the leading coefficient is 1. So what that means, you'd have to go back and watch a different video to get this part, but I know the end behavior of this graph. So from that video, if you go and watch it, actually let's link it down below. We'll link it below for you guys. And what that tells us is that our graph is going to start from down here, right? I know this problem isn't asking this, but just to help you connect the dots here, right? Because that's what we're trying to do. And our function is going to end up here. All right, so watch that video so you understand why. But right now we're just going to help you really see what this multiplicity does. So because I'm at negative 5 right now, the first 0, it has a multiplicity of 1. And because it's even, what I know is going to happen is my graph, when it's coming to touch it, it has two options. It's either going to touch it and go through, or it's going to touch it and bounce back. Because it's odd, I know it's going to go through. So there's the first piece of my graph. And right now, we don't care about how high it goes, right? That's a different topic. So it's going to go up, and then notice I have another 0 right here. So I have a 0 at negative 3. So then I know this function has to come back down to hit that 0. So let's look at this. Negative 3 has a multiplicity of 1. So because it's odd, right? Write that down. Because it's odd, it's going to go through it, right? It's going to go through that value. So it's going to turn around eventually and it's going to go through. We really don't care how far it goes down. We could cheat. Right, we could just plug in 0 if we wanted to actually know and know it's negative 75. But again, right now that's not important. And let's look at that last 0, which is at 5, right? The x minus 5 is a factor, but 5 is the 0. And it also has a multiplicity of 1, meaning once I get there, it's going to go through, right? And what's awesome is that's exactly what we expected to happen based on the information regarding the degree and the leading term of the polynomial. So you could see that all these pieces fit together perfectly, and now you have a good idea of how the multiplicity helps you out. So if you found value, please smash that like button, subscribe, and we'll see you mathletes in the next video. Peace.